Hello everyone, this is the first and the only recording for IM2 April 22nd, 2021. I love this meme. It said, on a scale of 1 to 10, how bad is your pain? Pi? Pi? Yeah, low level but never ending. And this is my response. Math teacher seeing this meme. Yay, finally. I thought it was funny anyway. All right, goal for the day. Appreciating pi. Pi is a very, very special number. I know it sounds geeky, but we are going to try to appreciate what pi is and why it is so special, and also practice mixing polygons and circle areas. So what is pi? I'm going to show you a quick animation of pi. Okay, so let's do that in slow-mo. Okay, so what we did was we drew 4 circles back to back, joined together, and we know that that represents the diameter. So of the circle, any size circle, that's a diameter, and that is one diameter length, and that is another diameter length, and that is another diameter length. And then we also put a red rope or length around the circle, and so that would represent a circumference. And the blue arrow indicates the starting point of that circle. So C is represented as the red outside length, which is the circumference. And then we start unrolling that circumference. Okay, so we start unrolling that length outside by moving that wheel to the right. Okay, so that remember the blue arrow is the starting point. So it used to be down here. And as it unrolls, so this is the starting and the end point, I should say. Okay, and it's going to unroll to indicate the length. And it just keeps on unrolling. And where it is after 3 diameter length, there's still a little bit remaining of the circumference that hasn't been accounted for. So 1 diameter length, 2 diameter length, and 3 diameter length, and a little bit more. That means that the circumference is a bit more than 3 times the length of the diameter. And to be more precise, the circumference is pi times the length of the diameter. So pi is a magic ratio. Okay, let's see that animation again. Okay, so regardless of how big or small the circle is, if it is a circle, the ratio, for any size circle, the ratio of its circumference divided by its diameter. Okay, so the circumference divided by its diameter, the ratio just means fraction, okay, is going to be pi. It's always pi, 3.1415926, so on and so forth. It goes on forever. And this is going to be fixed for all circles, regardless of the size. Whether it's a small circle, big circle, the ratio of its circumference to diameter is always going to be fixed. And so from this ratio, we get the circumference formula. When we multiply both sides by diameter to bring the then that cancels out, diameter cancels out from the left-hand side, and you're left with circumference is pi times diameter, which is what we have here. And when we replace diameter, since diameter is 2 times r, 2 times the radius version of the circumference is 2 times pi times radius. And we have now calculated never-ending number pi to about 31 trillion decimal places. That was in March 2019. So I am sure we have found a whole lot more. So 3.14 is the number that we usually use in our approximation, but it goes on forever. Okay, so this is about 500 digits. Okay, but you can imagine 31 trillion decimal places. So 31 trillion digits of are currently known, and the numbers are never repeating. Okay, so there is no pattern to it or whatsoever, and they just keep on trying to find the next digits. Okay, and this is a cool cup. Mr. McGovern, he's another IM2 teacher. His friend made it for him with all the pi digits. I thought that was pretty cool. Okay, how about the area formula of circle? Okay, that is area of a circle is defined as pi times r squared. How did we get that? And to do that, we are going to watch a short video. I hope that made a little bit more meaning to the formula area is pi r squared. Hopefully that will help you memorize this formula a little bit more. Now we're going to move on to investigating mixed circle polygon problems. The goal is to flexibly use the area knowledge you have and to sharpen your visual and analytical skills. You're going to be working on Desmos. There are 8 problems, and it's going to be worth 20 homework and classwork points. And there are 2 challenge problems that's going to earn you 2 extra credit points if you do good work. All right, so and any unfinished Desmos cards up to card number 15 will become your homework. There is no other homework. You can go into 3 breakout rooms are available for you if you want to work with friends. And click on I have a question if you need some help, and I'll be happy to hop on over. All right, so this is it for today, and I may be publishing the answer keys to the Desmos activity on Monday, but I have not decided that yet. So you are going to have to rely on your friends, your partners in class, so that you can answer these questions the best you can. And if you get stuck, don't forget to ask for help. That's it for today. Take care.